why do you need Kubernetes or a container orchestration engine? Kubernetes is just an example of or a type of container orchestration engine. So why do you need it? How does it work at a very high level? Let's begin with Docker. Now, Docker offers you two features. One is a runtime to run your application in this contained or a isolated environment. It provides you with isolation, so you can run two different processes in their isolated environment. One process does not affect the another, and so on, right? The second thing that Docker offers is the hermetic images or the standard packaging format. So once you package your application along with the runtime and create an image with it, it can run on your local machine or a laptop. It can run in a dev environment locally. It can run on a cloud in a production environment with the same way. So that's the standardization that it offers. Now, when you create an image, how do you run it is using typically a Docker run command. With Docker, you would use those Docker run command and you can run one container at a time on that machine. That's what you can do with Docker. Now, you can also compose it, use a Docker compose tool and run these services together, and they are launched as interconnected stack of services, and that's what Docker compose allows you to do. The problem with this though is it is limited to that one machine. You cannot cross the boundary of that host with Docker Compose. You cannot run containers on two different hosts with Docker Compose and so on. That is where the problem is when you move from dev to the higher environments like staging or a production environment. Because in a production-like environment, you're not going to have just one host where you're going to launch container, in which case Docker would have been enough. In a typical production environment, you'll have a bunch of servers. Let's call them as nodes. And then you would have to also deploy hundreds of containers a day because we typically do immutable deployments with containers. Now I want you to pause this video, think about the challenges that you could face in such environment when you want to run hundreds of containers on, let's say, hundreds of nodes. Note it down and then come back and resume. Now, the first challenge I am going to think about is how do I decide which container runs where, because I might have to run different types of containers on specific types of node. Let's say CPU intensive node, memory intensive node. I'll also have to know about resource availability. This is a typical scheduling problem. So the first challenge is scheduling. The second challenge is once you decide how to schedule, let's say it's not disparate set of services that you're running. We're talking about microservices which are interconnected. They need to talk to each other. So a container from one node needs to talk to the container on other. That's a networking issue. So how do you define this networking which spans across the nodes? How do you do the scheduling are the main challenges. Apart from that, you might desire certain features such as high availability, in which case you might have to deal with replication. You may want to scale your application, so auto scaling. Once you have multiple replicas, how do you connect to those? How do you distribute your traffic is where the next problem is the load balancing, or next feature you may need in your environment is load balancing. We're talking about these additional features. And then when you have one application which needs to talk to each other, to the other application, how does it discover that? So service discovery or the naming, possibly a DNS-based service discovery. So that might be another feature that you may want. Another could be the fault tolerance, or self-healing. So when your application goes down or one container goes down, it needs to be detected and replaced automatically. That's the self-healing. So having those features would definitely help you run your application with high reliability. And you also want to solve the problem of rollouts. How do you go from one version to another? And when that happens, when you want to do that, you might want to define a deployment strategy. Let's say you do it in batches, one at a time, and so on. So your application rollout. So all of these features would be desired in a production-like environment. And how do you set that up? As you might have guessed, the solution can be the container orchestration engine. And that's where Kubernetes comes in. And that's why you need Kubernetes. So after answering that why question, let's now talk about how Kubernetes actually would work. Now we are talking about container orchestration here. So we would be running those Docker hosts. So if you have one host, it's quite easy. You can connect to that and run containers on it. But let's imagine you have, let's say, 8 different nodes here. All of those are Docker nodes and you want to run containers on these 8 nodes. Now, either you can start talking to each of those nodes individually and make those decisions where to run those containers on which node and so on manually, or you can collect them and then put them in one logical entity. And that entity is how Kubernetes would look like to you. Because once you set up Kubernetes environment and this cluster, we are not talking to those 8 different nodes, or it could be 80 or 800 or maybe 5,000 nodes. You will always connect to just one entity, that is this Kubernetes environment. And internally it might have these masters or multiple masters, and some of these nodes would be dedicated masters, others would be just nodes. We don't have to bother about it. As far as the clients are concerned, they are not worrying about the nodes. We are not worrying about the nodes. We are not talking to the nodes at all. We are talking to just one cluster, one big entity, and that is what Kubernetes is. And that's how it looks like. That's how it works. So it collects all your nodes and creates a pool out of those nodes. And that makes it easy for you to understand, because you can always look at it as one entity, and you can run kubectl run, and let's say I want to run 4 containers or pods. We send it to the cluster and it automatically goes and launches it on some nodes. We don't have to bother about where it is running, how it is run, and so on. All we have to care about is, hey, I have this much capacity, these many CPUs collectively, and I can run my nodes on it. And when I need more capacity, I can add some more nodes to this pool. And that's how you can look at, that's how you'll have to start looking at the Kubernetes environment. You don't look at Kubernetes as, hey, I have this 4 node cluster and so on. So I just look at it as one cluster where I can run those containers, and it has these many CPUs collectively and memory collectively, and I can leverage that, and when I need more capacity, I can just scale it by adding some nodes. So that's the pool of servers which are available for this cluster. That's the right way of looking at Kubernetes, and that's how Kubernetes works.